Think you know the whole story? Turns out you were probably taught the half-truth. Welcome to Half-Truths. Close your eyes for a moment. Picture a moonless night, a forest thick with trees, the air still and silent. Now imagine trying to catch a mosquito in that blackness. Not just find it, but track its frantic, zigzagging flight and snatch it out of the air. Impossible, right? For us, yes. But not for a bat. We've all been taught how they do it. It's one of the first truly wondrous facts of biology we learn as kids, right up there with chameleons changing color or monarch butterflies migrating thousands of miles. Bats, we are told, are blind. To conquer the night, they gave up their eyes and instead evolved a superpower: echolocation. It's a perfect story. The bat sends out a series of high-pitched clicks, far too high for human ears to hear. These sound waves travel out, bounce off everything in the environment: a tree branch, a cave wall, a fluttering moth, and then return to the bat's exquisitely sensitive ears. From the delay and distortion of these echoes, the bat constructs a detailed, three-dimensional map of its surroundings in its brain. A sonic reality. It doesn't see the world, it hears it. It's elegant, it's dramatic, and it's the entire foundation for the phrase blind as a bat, an idiom baked so deeply into our language that we never think to question it. The bat is a symbol of navigating the world without sight. But what if that story, the one we learned from nature documentaries and science textbooks, isn't the whole story? What if that elegant trade-off, sight for sound, is actually a fiction? The truth is, that simple, compelling narrative hides a reality that is far more complex, far more capable, and frankly, far more interesting. Today, we're putting one of our most cherished biological facts under the microscope. We're going to unravel the half-truth that bats are blind. The story we all know is a masterpiece of biological branding. The bat is the undisputed champion of the night, the master of an unseen world. In this popular narrative, its blindness isn't a weakness, it's the very source of its strength. It's a classic tale of compensation. By losing one sense, another becomes extraordinarily, almost magically, powerful. This idea is incredibly appealing because it feels intuitive. It fits a pattern we think we see elsewhere in nature and in human experience. We imagine a blind person with a heightened sense of hearing or touch, and we map that same logic onto the bat. The darkness isn't a challenge for the bat. It's the animal's natural element, an arena where its unique adaptation gives it an unbeatable edge. Think about how this is portrayed. In cartoons, a bat will bonk into a wall in broad daylight, confused and helpless. In movies, they are often just disembodied squeaks in the dark, their presence felt but not seen, a stand-in for the eerie and the unknown. The science of it all just seems to confirm the story. Echolocation is so incredibly sophisticated, so effective, that it feels like it must be the only system at play. Why would you need sight if you can paint a picture of the world with sound? It's like having a military-grade radar system. You don't need to look out the window. This idea is so powerful that it has completely defined our perception of the animal. They are creatures of sound and echo, flitting shadows that hear their way through life. This image of the sightless navigator is tidy. It presents evolution as a series of clean transactions. You want to own the night and feast on insects when all the birds are asleep. Fine, says evolution, but the price is your vision. This turns the bat into a specialist, a creature perfectly and narrowly adapted to one specific niche. It's a simple, memorable, and powerful story. It makes for a great lesson in a fourth-grade science class. And like many of the best stories, its simplicity is exactly what makes it so misleading. The first loose thread in this narrative is so obvious, we almost never think to pull on it. If bats are truly blind, why do they have eyes? And they're not just tiny, useless, vestigial specks. On many species, they are noticeable, well-formed eyes. They look like they're meant to be used. And that's our entry point into the real story. The myth of the blind bat isn't new. It's a conclusion that was drawn, quite logically, from some fascinating 18th century science. Our journey starts with an Italian naturalist named Lazzaro Spallanzani. In the 1790s, he was obsessed with a simple question: how do bats navigate so flawlessly in total darkness? He brought bats into his pitch-black study and watched them fly around without ever hitting the walls or the furniture. He was mystified. His first logical assumption was that they must have some kind of supernatural vision, an ability to see in the absolute absence of light. So he decided to test it. In a series of experiments that would certainly not pass an ethics review today, Spallanzani began systematically disabling the bats' senses. He crafted tiny, opaque hoods to cover their eyes. He then released them into the dark room. To his astonishment, they flew just as perfectly as before. They never crashed. They maneuvered with the same effortless grace. The conclusion seemed inescapable. Their eyes were irrelevant for navigation. He wrote that a bat sees, so to speak, with its ears. He didn't know how they did it, but he had proven, he thought, that sight was not part of the equation. This was the birth of the scientific basis for the blind bat myth. Around the same time, a Swiss surgeon named Charles Guérin heard about Spallanzani's work and decided to take it a step further. If it wasn't their eyes, maybe it was their ears. Guérin took bats and carefully plugged their ears with wax. The result was immediate and dramatic. The moment they were released, the bats became completely disoriented. They crashed into walls, fluttered to the ground, and were utterly helpless. When he removed the wax plugs, they could fly perfectly again. Guérin had found the key. He sent his findings to Spallanzani, who replicated the experiment and confirmed the results. They had proven that hearing was the essential sense for nocturnal navigation. But in the process, a crucial misinterpretation took hold. Instead of concluding that bats used a combination of senses, the world seized on the more dramatic part of the story. Sight was unnecessary. The idea of the blind but brilliant navigator was just too good a tale to ignore. For over a century, the exact mechanism remained a mystery. Spallanzani theorized that they were sensing subtle emanations of sound, but he couldn't prove it. The mystery wasn't truly solved until the late 1930s, when a Harvard undergraduate named Donald Griffin, using newly developed audio technology, was able to detect the high-frequency sounds the bats were emitting. He was the one who coined the term echolocation. Griffin's groundbreaking work was a monumental leap in biology, finally explaining what Spallanzani and Guérin had observed. But it also had an unintended side effect. It cemented the myth. Echolocation was so amazing, so complete a system, that it overshadowed everything else. The focus was entirely on this incredible sonic superpower, and the question of their vision was largely forgotten. The bat was no longer just a creature that didn't need its eyes. In the popular imagination, it became a creature that didn't have functional eyes at all. The half-truth was now firmly entrenched as common knowledge. So, let's finally turn on the lights and see what's really going on. The single most important fact to correct the myth is this: no species of bat on Earth is blind. Not a single one. Every one of the more than 1,400 species of bat has eyes, and in every single one of them, those eyes work. The real story isn't about a lack of sight. It's about an incredible diversity of sight, tailored to the specific needs needs of each species, and a remarkable integration of two powerful senses. First, let's talk about the megabats. This group includes the largest bats in the world, the flying foxes. These are the big, often fruit-eating bats found in tropical and subtropical regions. If you look at a flying fox, the first thing you notice are its eyes. They are huge, dark, and very well developed, much like a cat's or a lemur's. And for good reason. Megabats primarily navigate by sight. They have excellent vision, especially in low light conditions, and some species even have color vision. They use their eyes and their powerful sense of smell to find ripe fruit and nectar-filled flowers, sometimes from great distances. For the most part, these bats do not use the kind of sophisticated echolocation that the smaller bats are famous for. They navigate the world visually, just like most other nocturnal mammals. The idea of a blind bat is completely shattered by the mere existence of these animals. They are living proof that the bat family tree is visually capable and diverse. They are, quite literally, the flying foxes of their name. Okay, you might be thinking, but what about the little brown bats, the ones that flit around our backyards at dusk? The insect eaters, those are the microbats, and they are indeed the masters of echolocation. This is where the myth gets its power. But even here, the idea of blindness is a complete fabrication. While their eyes are smaller and less powerful than those of a flying fox, they are fully functional. Their vision is perfectly adapted for the tasks they need it for. Think of it this way. Their echolocation is for the close-up, tactical work, while their vision is for the big picture, strategic work. Studies have shown that microbats use their vision for long-distance navigation. Echolocation is fantastic, but it has a limited range. The high-frequency clicks are absorbed by the air and don't travel very far, maybe a few dozen meters at most. A bat migrating or commuting from its roost to its feeding grounds can't use echolocation to see a mountain range on the horizon or to follow the course of a river. For that, it uses its eyes. Just like a sailor uses a telescope to spot land, a bat uses its vision to see large-scale landmarks and orient itself in the broader landscape. They can see the silhouette of a tree line against the slightly less dark night sky. They can detect polarized light, which helps them orient themselves using the pattern of light at sunset, like a natural compass. Their vision and their echolocation aren't two separate systems. They are a beautifully integrated duo. They work together, each providing a different kind of information. Vision gives them the general layout, the context. Echolocation gives them the fine-grained, immediate details needed to dodge a branch or, most importantly, to hunt. Imagine you're walking through a cluttered room in the dark. You might use your memory of the room's layout, your version of vision, to know roughly where the table and chairs are. But you'd use your hands, your version of echolocation, to feel your way around the specific leg of a chair to avoid stubbing your toe. The bat does this simultaneously. It sees the forest and hears the trees. Some research has even suggested that bats use visual information to calibrate their echolocation system, like a pilot using the horizon to make sure their instruments are reading correctly. They are not choosing between sight and sound. They are using both to create a richer, more detailed perception of reality than either sense could provide alone. The bat's brain is a phenomenal data fusion center, constantly cross-referencing visual and auditory information. This completely reframes their superpower. Echolocation isn't a compensation for a disability. It's an extra tool, a revolutionary piece of biological hardware that opened up an entirely new way of life. By developing this sonic sense, bats weren't replacing vision. They were adding a high-resolution, short-range targeting system that allowed them to become the apex predators of the nocturnal insect world. It's not like trading in your eyes for a cane. It's like being a soldier with excellent eyesight who is also given a state-of-the-art night vision and thermal imaging scope. It's an enhancement, not a replacement. The bat isn't disabled. It's doubly abled. It has a sensory toolkit that we can barely begin to comprehend. So, we journeyed from a simple, familiar story to a much richer, more intricate truth. We started with the image of the blind bat, a creature that sees with its ears, a perfect symbol of adaptation through sacrifice. It's a neat and tidy narrative that fits comfortably into a box, providing us with a memorable fact and a common idiom. But when we pulled on that one little thread, the existence of their eyes, the whole story unraveled to reveal something far more spectacular. We discovered that bats are not blind at all. We found the magnificent eagle-eyed flying foxes who navigate by sight, and the microbats who are masters of a dual sensory system, blending vision and echolocation into a single, cohesive perception of their world. Why does correcting this particular half-truth matter? Because the myth of the blind bat, while charming, does a disservice to the true genius of evolution. It promotes a simplified, almost cartoonish view of the natural world as a place of simple trade-offs. You gain this, you lose that. But the real story of the bat shows us that evolution is often a process of addition, of integration, of building new layers of complexity upon the old. The bat didn't trade its sight for sound. It kept its sight and then invented an entirely new sense on top of it, one that allowed it to unlock the vast, untapped resources of the night sky. The story we tell about bats shapes our understanding of perception itself. By insisting they are blind, we project our own limitations onto them. We assume a sense as dominant as vision must be the only way to truly perceive the world, and that any alternative must come at its expense. The bat proves us wrong. It lives in a world of sight and sound, of light and echo, a fused reality we can't directly experience, but can, through science, begin to appreciate. The half-truth of the blind bat isn't just a mistake in a biology textbook. It's a failure of imagination. Now you know the real story. What other half-truths are still out there? If you enjoyed this episode, please subscribe, leave a comment, and join us next time. Until then, stay curious.